Right, okay guys, so we're going to have a look at a quick video on some worked examples in EZ isomerism problems. What we're really going to do is, how do we take a structure or a name and decide if it actually does contain geometric EZ isomerism? Okay, if you remember from the last video, and it would be most useful if you had looked at the last video prior to doing this one, the criteria that we're looking for, first of all, is there a carbon-carbon double bond present? So if there's not a carbon-carbon double bond, we simply can't have EZ isomerism. And then the groups on either side of the double bond, so I've called them groups A and B here, are they different? And then the groups on the other side, D and E, are they different? So that has the criteria you've got to meet in order for EZ isomerism to exist. So we're going to look at, first of all, deciding whether this compound that I have on the board, 2-bromobutene, does have it, and then we're going to draw out the E isomer and the Z isomer and show how we go about labeling them. So the first thing I would do here, I suggest that you just draw this out normal straight chain. So we've butene, so we've butene, so 4 carbons with a double bond in them at position number 2, and we have a 2-bromo, so we have a bromine there, and then everything else are hydrogen atoms. Next thing that you should need to be able to do is then bring that into a configuration where we put our 120-degree bond angles around our 2 carbons in the double bond, and then we've got to decide what are our groups equivalent to our A, B, D and E groups here. Okay, so on this one, on this carbon here, we have a bromine, of course, so let's put that on there, and here we have a CH3. Okay, so on this carbon, okay, we have a hydrogen here, and we have a CH3 group also attached to that carbon in the double bond, so we have a CH3 group there. Right, so we've got to ask ourselves then, do we have a double bond? Well, yes, of course we do. Is our A and B groups, so our groups on the left hand side of the double bond, different? Yes, they are. And on the right hand side of the double bond, are they different? Yes, they are. So therefore we do have EZ isomerism. Our next challenge then is to name this isomer as, is it E 2-bromobutene or is it Z 2-bromobutene? Right. So let's have a look at that. Right, so when we're naming EZ isomerism, we go to the atom which is directly attached to the carbon in the double bond. So if I deal with the left hand side carbon first, and I go to the bromine, and I assign my priority number, which is the atomic number. Bromine is 35, carbon is 6. So therefore that is my high priority group on the left hand side. And if I go to the right, hydrogen has atomic number of 1, carbon is the atom directly attached to the carbon in the double bond, so that is 6. Therefore this is my high priority group here. I have my 2 high priority groups on opposite planes of the carbon-carbon double bond, so that therefore means that I have my E isomer. So that is called E 2-bromobutene. If I was asked to draw the Z isomer, well then all I would do there is swap that group with that group and redraw it. Okay, so that's how you take a name, turning it into a simple structure, turning it into a structure which will show you the presence of the E and Z isomers, and then how you convert the E isomer over into the Z isomer. Right, let's have a look at another one. Okay, so we'll look this time at 3-methyl pent-2-ene. Again, we'll draw it out, straight chain, so we've got pent-2 as our main chain, so let's do 5 carbons with a double bond between on the second one, and we have a methyl group on the third carbon, so it's there, and then everything else is just saturated with hydrogens. Okay, we then take the double bonded carbons and draw them as so, putting our bond angles in. Now we've got to work out what are our groups on this. So here we have on this carbon a hydrogen and a CH3 group, and on this carbon we have a CH3 group as well, and we also have here then a C2H5 group. So let's check, do we have the criteria? Do we have a double bond? Well, yes, of course we do. Do we have 2 different groups either side? Well, here we have a hydrogen and a CH3, so yep, A and B are different, and over here CH3, C2H5, So they're different. So we do have EZ isomerism. Now we've got to decide which of these isomers are actually the E and which one is the Z. So let's have a look. I'm going to draw this out just a little bit fuller, just to make it easier to see why or how I decide. So I'll just draw my full CH3 and C2H5 groups out here. Okay, so let's have a look. This side's pretty easy. I have hydrogen here, that's 1, and directly attached to the carbon here is carbon, which is 6. So that's my high priority group there. Okay, then over here I have carbon here, which is 6, but I also have carbon down here, so I can't use those carbons to assign priority. So what do I need to do? I need to go to the next atoms that are directly attached to those carbons. So here I have hydrogen, hydrogen, and hydrogen, so that's 1, 1, 1. And down here I have hydrogen, hydrogen, and carbon directly attached to that carbon. So that is, I'd list the carbon first because it's got the highest atomic number. So that's 611. So therefore this group is my high priority group on that side. So therefore this isomer is my 2 high priority groups from the same plane. That's my Z3-methyl pent-2ene would be the name of that. And again, to turn it into the E version, I simply swap this group, okay, with that group, or this group with that group, but of course not both, otherwise you just have the same molecule upside down. Right, I'm going to do one more worked example here, and that will do us. Okay, so let's have a look at 2 bromo, but 1 ene this time. So again, bring it down, 1, 2, 3, 4, into my butene. But 1 ene, the double bond is in position number 1. I have a bromine on position number 2. So I just draw everything in then, which are my hydrogens that are left over. Okay, bring it down, put my double bond there with my bond angles around it. Decide what groups I have. So if I do this one here, this carbon on the right first, I have a bromine and I have a C2H5, just draw it like that. Okay, and on the left hand side I have 2 hydrogens. So do I meet the criteria for EZ isomerism? Well, I have a carbon-carbon double bond, yes. I have 2 D and E groups on the right hand side of the double bond are different, so that's fine. But the 2 groups on the left hand side of the double bond are both hydrogens, so therefore they are the same. So A and B groups are the same, so you will not be able to get EZ isomerism, okay, from in this particular example that I have on the board now. Okay guys, hopefully that helps. There's another couple of examples in the previous video, one quite difficult one at the end, which I think if you can do it for AS level chemistry, you will be fine with any problem that comes your way in an exam. Okay, hope that helps.